Hello everybody. I wanted to do that dog on the scale in the elevator problem, and you may recall the reason we didn't do it on the last block day last week was just it had been a lot of talking, a lot of sample problems, and a new concept, this vertical concept. You'll recall that we introduced this idea that the upward force, which we're calling F normal, and the downward force, which we always know to be weight, mg, that if one of these is larger than the other, if they're not the same, then the object is accelerating in the vertical direction. Now in this problem, we have a scale in an elevator, and there's a dog on it. The dog has a mass of 50 kilograms. So let's calculate quickly what the weight is. The weight would be 50 times 9.8. That's 490. So if the dog is not accelerating, either standing still or moving with constant velocity, either way, then we know that this would be the same. So if no acceleration, then Fn equals mg equals 490. A quick word. What the scale reads is how hard it pushes up on the dog. And so when the problem asks what is the scale reading, it's going to be 490 if the dog is either at rest or moving at a constant velocity. Now, they tell us that the dog is going upward at 2 meters per second at first. So I'm going to make an old school list, a Vivacsta list. And you may wonder why I'm doing that, but I need to determine if there's an acceleration, because if there is, then we have a different situation. So it says initially the dog is going plus 2 meters per second, upward at 2 meters per second. And then it says that the elevator comes to rest in 1 second. So the final velocity of the elevator is 0, and time is 1 second. Well, if we don't know the distance, but we want to find the acceleration, we can do that. You may recall the equation that doesn't have x in it is the first equation. So v equals v naught plus at. Solve for a, I get final minus initial over t. And that's 0 minus positive 2 over 1 second. 0 minus 2 is minus 2 over 1 is minus 2 meters per second squared. So that's during the time that the dog is stopping. The elevator is coming to rest. It's going up and then it stops. And that's the rate of acceleration while it stops. But part A of the question says, what is the reading on the scale during the time the dog is traveling upward at 2 meters per second squared? I'm sorry, at 2 meters per second. Well, while it's traveling at a constant velocity of 2 meters per second upward, there's no acceleration. So for part A, the reading on the scale is 490. Now, if you want to use an equation to get there, you would say up minus down equals ma, because F equal, this is the net force, and this is the net force. They are both, F net is ma, and F net is up minus down. But a is 0. And 0 times 50 is still 0. So we know that up minus down equals 0. And we know down equals 490. In other words, we know that in this situation, Fn equals mg, and the answer is 490. The reading on the scale equals 490. During the acceleration, we know the acceleration is -2 meters per second squared. Acceleration is actually in the downward direction because you were going up and you stopped. So that net force is downward. So for part B, we want to know the reading on the scale. Let's change color. Up minus down equals ma. What are we looking for? We're looking for the reading on the scale, which is the normal force the scale exerts on the dog. So moving this negative mg to the other side makes it positive, and we get Fn equals ma plus mg. So now let's just do the calculation. Fn is equal to 50 times -2 meters per second squared, because that's the acceleration we calculated using our kinematics formula in equation number 1, plus mg. And I could calculate it again, but we know it's 490 newtons. -2 times 50 is -100. So the normal force exerted by the scale is -100 plus 490, which of course is 390 newtons during the acceleration. I know I might have gone a little fast, so I am going to put this on YouTube so you can watch it again if you need to.